Welcome. Today's experiment is Mux and Demux using Verilog HDL data flow modeling. So regarding multiplexer, we have 2 power n input data lines, n select lines given to the mux, and we get one data line as output. So this is the diagram, and the formula is y equal to d naught s bar and plus d1 s. So while writing the code in data flow modeling module, I give mux21 as the name, y comma s d naught comma d1. Output is only y. Inputs are the select line s and the two inputs d0 and d1. Assign y equal to not s and d0 or s and d1 and end module. So we go to Xilinx. So open new project. In the project, open new source and Verilog module. Give mux. Mux21. I give to 1 because it's a 2x1 mux. So we have written the code here. So first we need to check syntax and then view RTL schematic after checking the syntax. So this is the diagram for the multiplexer 2x1 mux. Then followed by we go for launch model sim simulator to check the output. So as per the truth table, so whatever is the, when s is equal to 0, whatever is there in I0 will be there in y. When s is equal to 1, the input there in I1 will be there in y. So when s is equal to 0, I0 is the output. When s is equal to 1, I1 is the output for the 2x1 multiplexer. So on opening the multisim, so we have y is the output line, s is the select line, force, and I give value 0. Okay, so let me give value in d0 as 0 and in d1 as 1. Okay, so when we run the program, we get so whatever is there in d0 is there in y since s is equal to 0. So when I keep s is equal to 1, state, so state 1, whatever is there in d1 will come to output y. So d1 has value 1. So output now becomes 1 since s is equal to 1. So this is regarding 2x1 mux. So next let us see the 4x1 multiplexer. So let me close this model sim simulator. We have the program for 4x1 mux. So this is the diagram, logic diagram, and this is the equation. Assign y equal to s of 1 and not s of 1. So we have a not here, not gate here, s of 0 and I not. And this is the formula for multiplexer, 4x1 multiplexer. So we have written the code mux. You name the file as mux 4x1. So code is written. So in this again we need to check the syntax to check if there is any error in the program. So if there is any error, it pops up here in the console. So syntax is checked. We may check the RTL schematic also. This is the diagram for the 4x1 mux. Then we go for InDesign utilities, launch model sim simulator. So here the truth table is for 4x1 mux. So this is the truth table. So when the select line is 0 0, C0 is the output. Y will have this value in C0 for 0 0. So C0 here the C0 has 0, so the output is 0. Here C0 has 1, so the output is 1. So when the select line value 0 1, whatever is there in C1 is the output. When the select line value is 1 0, whatever is there in C2 is the output. For 1 1, whatever is there in C3 is the output. So we can also check here. The S is given as a two input. So it is 1 0 S is given. So it will have two values, S of 1 and S of 0. We check both individual values separately. So while running the code, we need to give the value for S as two values. So let me give 0 0 and I naught. I'm giving 0, I1 1. Let me give I2 as 1 and I3 as 0. So when we run the program, we have for 0 0, whatever is, since the S is 0, whatever is there in I naught will be the output. I naught is 0, so the output Y is 0. So let us change the value for S as 0 1. So whatever is there in I1 should be the output. So this is 0 1. So I1 has 1, so the output has become 1. So for 1 0, whatever is there in I2 will be the output. For 1 1, whatever is there in I3 will be the output. So we may also use a test bench code for the same using behavioral modeling. That's also fine for all 4 inputs. So next we have the Demux 1 cross 2 Demux. So this is the code. So the truth table for the the code for demultiplexer is the diagram, and assign y naught equal to not S and A, and assign y1 equal to S and A. So here we have the outputs y naught and y1. Input is A and S. Regarding the truth table for 1:2 Demux, so when S not equal to 0, when S is equal to 0, when select line is equal to 0, whatever there in D, I mean whatever there in the input will be in Y1. When S is equal to 1, whatever there in input will be there in Y2. So if S is equal to 0, Y0 output is selected. When S is equal to 1, Y1 output is selected. So when we run the program, so we need to check the syntax of this first. This is the RTL schematic of 1 cross 2 Demux. After that, go for launch model sim simulator. And we may check with different inputs. So we have the in pairs per the code. So the outputs are Y0 and Y1. Input is A and S. So A and give value 0, and S and give value 0. So when we run the program, we get the output for all as 0. Since A has 0, Y1 will have the same. So now suppose and give value for S as 1, and let me give the value for A as also equal to 1, so that we can check the output clearly. So now S is select line is 1, so whatever is there in the input A comes to the output Y1. Right? When S is equal to force again, when S is equal to 0, and we run the code, whatever is there in A is there in y0 and not in y1. This is regarding 2 1 cross 2 Demux. Next we go for the 4 cross 4 1 Demux. So we have the code here, 1 cross 4 demultiplexer. This is the circuit. So assign values for y1, y0, y1, y2 and y3 and n module. And this is the diagram. So what we do here, as per the truth table. So we have the values for S0 and S1. So when it is 0, 0, then whichever we given the input comes in the output y0. For 0, 1, the input comes in y1. For 1, 0, the input comes in y2. And for 1, 1, the input comes in y3. So this is the code. It has a small problems. I have altered it lightly. So I have again given S as 0 is to 1. Yes. So the input variables are only A, output variables are in another input we have S, which is a 2 input variable 0 1. So we have S of 1 and S of 0, similar to 4 cross 1 mux. And the output variables are y0, y1, y2 and y3 and n module. So after selecting that 4 1 mux, check the syntax and view the RTL schematic for the 1 cross 4 Demux, and then go for launch model sim simulator. So A and S are the inputs here. So let me give value 1 in A so that we may check the outputs. So I'm giving the value 1 here, and S is, let me give 0 0. So the A value has to come in y0. So next is when I change the A value to 0 1 and run the program, the A value is there in y2. And I give value 1 0 in the select line. I run the program. The value of A is there in y1. And the last input y1 1 1 for select line, we get the value of A in y3. A value of A is 1, it is there in y3. So this is regarding the 2 cross 1 and 4 cross 1 mux and demux. Thank you.